We're going to get started because we have a lot of content to cover today. So thank you for joining us again. My name is Jared Oren. I'm the Test and Evaluation Division Director here at the National Urban Security Technology Laboratory, or NewSteel, and we're in New York City. NewSteel is a laboratory under the Department of Homeland Security, the Science and Technology Directorate, or S&T. And for today's webinar, we've assembled state and local first responders. You may be a state administrative agency personnel. You may be other state and local government personnel. We do have a lot of federal partners on with us today as well. But we're going to spend up to 2 hours with you all talking about countering drones. It's a hot topic, and we're really excited to put out some information with you guys. And by the way, we're co-hosting this webinar today with drone responders, Charles Werner, and more on that in a second. But he's been a critical partner for us with NewSteel and within DHS more broadly on a variety of drone and counter drone topics recently. So we're really pumped to have this collaboration today. But yeah, so the purpose of today's webinar, by now you're all aware that FEMA's posted a Counter-UAS grant program, Notice of Funding Opportunity, or NOFO. And for FY26, that's initially targeting the FIFA 2026 host sites, so 11 host sites, as well as the NCR separately, so 12 total localities, as well as, this funding's targeting the America 250 celebrations, for next summer. So hopefully you're not all still in scramble mode to finalize your proposals, which are due Friday, 5 p.m. Eastern. But yeah, so we're here to discuss sort of the second phase around this notice of funding opportunity. I think it was November 6th. And many of you joined previously, sort of the administrative side of this this Counter-UAS program, notice of funding opportunity, and the FEMA hosts covered a wide range of how to apply and the sort of administrative procedures. So we're not going to spend any time on the administrative side today. We will remind you of a couple things, though. But we've got a number of technical topics to sort of start the conversation with you all from the NewSteel perspective, so that you realize that we are a resource that you can tap into us, not only between now and the grant application, which is sort of foregone conclusion for you all at this point, being due this Friday, but really between now and next summer, right? There's a wide variety of topics on Counter-UAS considerations that you hopefully will adopt and treat this sort of a combined state, federal, local approach to countering drones. And there's a lot of key concepts. There's a lot of real test and evaluation data. There's a lot of on-site assistance things that we can do, and so on and so forth. And we're going to get into all that. But before we do cover some of these topics, I want to pass the floor over to Alice Hong. She's our NewSteel Laboratory Director. So go ahead, Alice.
Good morning, everyone. I'm going to repeat a few things that Jared said, just because so many people are still joining the call. As Jared mentioned, I'm Alice Hong. I'm the director here at the National Urban Security Technology Laboratory. That's a mouthful, so we mostly just call it NewSteel. We are an asset under the U.S. Department of Homeland Security Science and Technology Directorate, and we are located here in downtown New York City. And as you know, the deadline, as Jared mentioned, for the first of 2 grant installments for this NOFO is approaching specifically this Friday. I'm guessing that many of you are strangers to our lab, but we're going to change that right now. So before we begin, I just want to do just like a quickie background on what we do here at NewSteel. Our congressional mandate is to equip state and local first responders with the knowledge, the tools, equipment, technology that are needed to advance public safety missions. We do this for jurisdictions nationwide. Most of this is done by testing the equipment that your agencies will purchase and deploy in the field. We're the only federal lab solely dedicated to supporting state and local first responder agencies like this. And, today we'll be focused on Counter-UAS, but I just want everyone to be aware that we assess a wide range of products for public safety, from PPE, such as body armor and tactical eyewear, to body-worn cameras, to much more complex and sophisticated sensor-based systems like CBRNE detection systems, drones, counter-UAS, weapons detection systems, all which may have a role in World Cup and other special events that are upcoming. In any case, we're a free resource to state and local, so please reach out if you need any support on any current or future tech needs, as we want to make sure basically that every dollar you spend, whether it's yours or coming through federal grants, that it's driven by informed, data-driven decision making. Obviously navigating this world of, rapidly evolving and increasingly complex technology, and also trying to navigate the federal government system of bureaucracy can be quite the headache. So please consider us your belly button whenever you need help on these issues. So back to the topic du jour, counter-UAS. With the urgency of this funding opportunity and the prioritization of World Cup host cities and the NCR, we want to ensure that all the technical support, tools, test data that are available at our lab are fully accessible to all of you to assist you in making, again, data-driven, informed product selection decisions. We're really thrilled to have what looks like a very healthy turnout today. And before our speakers begin, I'd like to just take a moment to introduce one of our very valued and critical partners in advancing the public safety mission when it comes to drones and counter-UAS, and that's Chief Charles Warner, who is one of the founders of Drone Responders. If you aren't familiar with Drone Responders, they are an excellent go-to resource on all things UAS and counter-UAS. Especially for the practitioner community. And they are so committed in advocating for the needs of our public safety partners. So Chief, please say hello and we'll get started.
All right, Alice, thanks. Can we pull up the slide? So first, I'd like to thank New Steel for really stepping up and jumping in. They're bringing the technical and the engineering background, which is going to be very important for some of the technologies that go forward. Let me just talk a little bit about Drone Responders in case you don't know. Drone Responders is the largest and leading nonprofit program to advance public safety UAS, counter-UAS, advanced air mobility, and airspace awareness. We now have just under 13,000 members. We have participation from 92 countries and over 500 international members. I just want to let you know about the resources. Membership to Drone Responders is free, as well as the resources that we offer. And just so you know what we do offer, we have a program directory which shares information of drone programs from public safety across the United States. We're just about at 1,900 agencies sharing their information. We have a resource center, which again is free to you to access to get all the information. There is a counter-UAS folder in there as well, and a C-UAS grant folder. I also posted in the Q&A a link to the most recent list of things I put out, which include everything as far as DHS, counter-UAS. There were a lot of documents in different places, so I put them in one singular place with a link that you could get to. We also have our upcoming events. We have an app. If you have the app, you can keep up with everything that takes place. And then you can see our partner organizations. We have monthly webinars with the FAA, the second Wednesday of every month at 4 p.m. Eastern. We have the Public Safety Drone Review monthly, the first Tuesday, which we talk about news stories, and we have a public safety highlighter. We have women drone responders capturing and sharing and celebrating the successes of women in this field and encouraging girls and women to consider this as an opportunity. And we now are developing drone responder state chapters and coordinating groups. And we have working groups like Major Cities Working Group, Counter-UAS Working Group, the Drones and First Responder Working Group, the Flotation Device Working Group, and many more. So go to droneresponders.org or get the app and find out what we're happening as far as all of our events. We have an event coming up, actually one happening right now, TexCon in Texas. We have Florida the FlowCon, which will be in February, and in March, we'll have the national conference in Williamsburg, Virginia, at Busch Gardens. So check it out, see what we're doing. But I want to go back now to talk about New Steel. We've been having discussions over the past year, and what's really positive and hopeful is that we'll have conversations how New Steel can further support public safety at the SLTT levels. And they've been so engaged that we're looking forward to be able to present things like the drone, the blue drone testing that was done, to give the results of that and other similar type of activities, but also to hear from you all as to what will be helpful as we move forward. And with that, I'm going to say thanks for allowing me to be here and be a part of this, and thank you all for doing this. And I'll turn it back over to Jared.
So we have a number of speakers today. I appreciate Charles Marks already from Drone Responders. We have a few New Steel speakers on one or two topics each today. So we're going to jump right into some of those topics. First, I want folks to I want to recap where we're at with FEMA Counter-UAS grant program. So you have two QR codes here. The first top right shows frequently asked questions, and there was already a webinar course by David Godinez and Kerry Thomas and the FEMA team. And hopefully you got all your questions answered there. But if not, you see that there is a email address. So please direct your administrative type questions for the grant process, through the life of the grant process, to this email link you see here. So like I said, on the administrative side, you've got this FEMA inbox. Please use that. On the New Steel side, for technical topics, we're just starting the conversation today. So we expect that you're going to have follow-on questions for us, and we'd be pleased to have some iterative dialogues with you all. And so New Steel inbox here. And again, we're available to provide technical support prior to submission, which of course we're running out the clock there. But well beyond that, right? Before you purchase and receive your equipment, after you receive your equipment and you do some find more detailed level planning, placement assistance, consider your overall system that you're putting in place, and considering the federal assets for the different events you're hosting next summer versus your local assets. There's just a lot to consider here, both from a map-based planning perspective and in person. And we'll talk more about that. So New Steel inbox to continue some of those discussions, and we'll look forward to those one-on-one conversations. We just got this FIFA 2026 support request form email, or a web link for you all to fill out. Just be aware this is out there. You should be working, each host city, each SAA should be working with your federal coordinating officer, or FCO, as you plan FIFA and America 250 celebration and federal assistance items. The way that DHS is consolidating those requests is through this web form. So you should consult your FCOs for more information about that before you decide what you're requesting and why. Just work with your FCO. We won't be involved with that, but certainly we can help you on a variety of things as well with New Steel directly. So hopefully the slides are advancing for everyone at this point, with probably a bandwidth issue.
Yep, we see
good
it.
problem to have. Go ahead.
Oh yeah, we see the slides.
Okay, great. At least some of you. So we're going to start with going over some counter-UAS terminology and key concepts that you should be considering as you're thinking of beyond just purchasing one or a couple of types of sensors. What are the DHS-wide types of terms, standardized terms to use here? We are consistent with FBI's training that some of you have attended recently, hopefully, at the Huntsville National Counter-UAS training course, hosted by the FBI CERG folks. And just by a show of hands, I'm curious if we have any in the audience who has recently been to that FBI course or is soon to be going. Chris, thank you. Tiara? Excellent. And there's probably other hands raised here that I can't see from my screen at the moment. But feel free to drop in the chat line, the Q&A, what you thought about the course. We heard a little bit about it from one attendee yesterday and was thrilled about the course. So that's fantastic. We're this quick tutorial on key concepts is consistent with that training, but certainly doesn't replace it. So go ahead, Bargraf.
Thanks, Jared. Yeah, so we're going to start off by kind of rehashing some of the key concepts so that we're all speaking the same language. And we'll start with the continuum of events. It's the framework for how to view a Counter-UAS problem. My definitions and point of view is a little bit more from the technology side and how to kind of view the threat as it walks through the way sensors will interpret things and display things back out to operators of Counter-UAS technologies. We call it the continuum events or processing chain. I think in the DoD, they may still call it the kill chain. Next slide, please. I'm still stuck on a continuum. There we go. So you have detect, track or locate, classify, identify, and mitigate are the big buckets to view these within. Next slide. So the first piece is detection, the declaration that your sensor sees a UAS or a candidate target for a UAS and that it's in its presence. People will often conflate this with geolocation. I like to keep them distinct and separate. There are quite a few systems out there that are just looking to see if they have RF signals emanating from a drone in their area without giving you any information about their location. And that could be coming from the aircraft itself or the ground controller. And different systems will have different thresholds for when they will trigger an alert to the reporter as to whether or not it sees something. Next slide. Track and locate. I like to think of locate as a static estimation of where a drone or ground controller might be. Over the years, I've seen this displayed to an operator in a lot of different ways. Sometimes you'll get really low fidelity, and that might look like a quadrant lighting up. You know, you might get like a pizza shaped slice on a map, and it says something is there. You don't know where on the map, we're in that little wedge, how far away. Other times you might get maybe more fidelity, a heat map display, right? There's a high probability that something's in this orange blob on your map. More and more, we're seeing high fidelity indications of where a target is, and you'll get a lat long and altitude. All these come with some level of error and estimation built in. And then a track is often associated with things like a radar, but other systems will do too. It is the compilation of those static reports over time as they associate with a single target or item. And so with radars, for example, you might get multiple tracks from the same drone, and that's a drone kind of coming in and out of the radar's line of sight. And then sometimes you get multiple tracks from different targets. Some might be a bird, some might be manned aircraft, some might be the drone itself that you're looking for. Next slide. I like to, a lot of people use classify and identify interchangeably. I like to kind of add a little level of distinction. So classify to me is the broader category. Is it a drone? Is it a bird? Is it a plane? Just something that gives me a better idea of what I'm looking at. And then identification I tend to use to assign a little bit more specificity, right? So is it a drone and is it a quadcopter? Is it perhaps a specific make and model that I'm aware of, or a specific communication profile protocol that my RF sensor is aware of? And so if you choose to use these interchangeably, be welcome to, but also know that once in a while you might get some distinctions depending on who you're talking to. Next slide. Mitigate, negate, interdict, neutralize. These are 4 terms that are often used interchangeably to describe anything you do to remove or reduce the risks of a threat posed by UAS. And we're going to get a little bit more into this later on. So that's the framework. I'm going to move on to sensor types and methods. Next slide, please, or next 2 slides, perhaps. Before we get into any of that, I want to talk about some factors that are really important to radio frequency detection, but may apply to really any sensor that you use. So all of these Counter-UAS sensors operate at their most optimal state and configuration when that sensor has direct line of sight to its target, so the drone in the sky or even the ground controller on the ground. We don't live in an ideal world where that's going to happen all the time, and so just know that the more obstacles you have between your sensor and your target of interest, the more lower fidelity, lower accuracy you're likely to get in terms of declarations of detection or geolocation information. A lot of these systems also rely on libraries, right? A set of known parameters that reliably represent the threat. Your library might contain, you know, the RCS radar cross-section for 100 different drones, and it might contain the RF, like digital fingerprint, for only 20. It's important for you to understand what is and is not in the library of the system that you are looking to acquire and use for these operations. Noise floor is another thing, right? So let's use a really obvious example. If I have an acoustic sensor, right, an array of microphones listening for drone noises, well, that's going to work pretty well if I'm in a sparse populated environment like the southern border or an open field out in, you know, rural America. That same acoustic sensor is not going to do anything for you if you're in a really noisy environment, such as, you know, Times Square or right next to an airport. And so understanding your environment is very critical to making sure that you are getting the most use out of your sensors. Next slide. So generally, I tend to have like a full slide for each of these sensor modalities, but we'll keep it a little bit at a higher level. The most common ones are passive RF or passive radio frequency sensors, radars, electro-optical and infrared cameras, and then acoustic sensors. They all have their pros and cons and are probably have ideal conditions in which you'd want to use them. Next slide. So this next slide is just kind of a preview. We have a document, and I think Charles shared it in his link, Google Drive, of Counter-UAS questions to ask vendors, right? And so these would be some obvious ones for these types of sensors. If you're looking at a passive RF sensor, you want to know what's in the RF library. What is it definitely going to see, and what is it definitely not going to see? Is there a very popular drone that just doesn't happen to be in your library and I'm not going to be able to detect it? Well, maybe I don't want to make use of that sensor and go forward with that acquisition. If you're looking at radars, understanding how far, what the range is of reliable detection of drones of interest, right? Are you really interested in large agricultural drones, small drones, and at what distance? Another interesting one is just FCC approval. A lot of these radars might only have experimental licenses where you need to get special dispensation from the FCC to make use of them in certain areas. And the questions go on for cameras and acoustic sensors as well. We have a full document that lists out, I want to say, at least a dozen questions for each sensor modality. Next slide, please. In an ideal world, you're operating with many sensors in your system that are integrated and working in tandem. So here we see an example where we have an RF sensor, a radar, and an acoustic sensor, and they're working together to provide a more robust and higher confidence detection and geolocation of a drone. And then it might cue a camera system to look in that direction where it thinks a drone is being detected and provide you or your operator with a visual confirmation. Sometimes these sensors are working in tandem with each other, or sometimes it's all being fused together to provide you with a single kind of layered defense and single picture of what the threat looks like instead of many different layers. Next slide, please. We're going to get a little bit more into mitigation. We'll go one more slide, and this is just to remind you that, you know, these are all terms that tend to be used interchangeably, and we're looking to remove or reduce the threat posed by small UAS, and it's the last step in the processing chain here. Next slide. The grants NOFO has some language in there about who may be eligible to purchase technologies that make use or have mitigation features in them. This is a snippet of that. I think there's a little bit more verbiage in the grant itself. I'm not a lawyer, so I will not linger too much here, but I do know it's tied to having personnel trained at the FBI Academy down in Huntsville. Next slide. So we're going to go over the most common mitigation techniques and attacks. I have three big categories for them. They're electronic attacks, kinetic attacks, and then locating the operator. Locating the operator is the technique that is currently most available to state and local first responders. You're going to see a few crossed out items here. These are items that are not commonly used CONUS and come with a lot of collateral issues and damage, and so we will not be delving too deeply into those. Next slide. So a while ago, we tried to create a taxonomy of sorts of all the mitigation methods, and this is just a quick snapshot of what that looks like and kind of where things live in relation to each other and within a hierarchy. The items in red boxes are the items that we're going to cover. And then, just another quick reminder that in order to make use of these methods or purchase equipment that can do this, you have to have received training from the FBI and C-UAS Academy. Next slide. So electronic attacks, I'm going to talk about two broad categories, which are exploitation or cyber attacking, sometimes called hacking, and then RF jamming, which can be broadband jamming, smart or targeted jamming, and that comes into variants as well. You'll see the image of the guy with the RF jammer gun. That's a more directional form of it. You're kind of shooting a cone. And then below is a kit of what is an omnidirectional jammer, which is radiating in all directions, creating a sphere of broadband RF jamming. Next slide. So I'm trying to kind of condense some things here, and I'm going in the order of what might have the least collateral damage if it works well. So with some of these devices that can exploit some kind of vulnerability between the ground controller and the aircraft or the RF communication protocol, you're often going to have your Counter-UAS system masquerade as a legitimate ground control source and take advantage of some kind of bug. And so there's a world of opportunities that open up to you. Not all the systems do the same thing, but if you have one of these systems and you're exploiting a library of a known drone and making use of this, you might be able to obtain sensitive information about that small UAS. Everything from where it is to serial number to other information that might be sent off between the aircraft and the ground controller. It could be things like battery life, received signal strength, and you could potentially eavesdrop this all in real time, including video. You could fully take it over and tell that drone where to land. You could send it over to a safe zone. You could also, if your exploitation tool allows it, potentially send augmented reported telemetry information. You can send it fake information about where the drone thinks it is in the world and start moving it in a different direction without the ground controller noticing right away. These methods are highly dependent on the communication protocol being exploited and understanding what is and isn't in the library for that exploitation to take place. It does come with some of the lower amounts of collateral damage. In an ideal world, you are just directing that drone to land in a safe zone or sending it back to the operator if you don't think it's nefarious. Next slide, please. So RF attacks, they come in a few different flavors. If your technology has what we call kind of smart jamming or targeted jamming, it's looking at the digital fingerprint of how the ground controller is communicating to the aircraft, and it's just trying to step on those little packets as they're being sent almost at the same time. And so, in an ideal world, when that is successful, the drone is not able to receive legitimate signals from the ground controller and will either go back to the operator or where it launched from and land in place, and no one else in the vicinity is adversely impacted. If it doesn't work ideally, someone's Wi-Fi or anyone else operating on that signal might start to see issues with their connectivity. Broadband jamming, it's kind of as described, you are trying to jam the entire frequencies bandwidth. So like in this image, we're looking at 2.4 gigahertz, which is the Wi-Fi ISM band. And so if you're jamming on this, you're going to jam anyone that's making use of 2.4 gigahertz in the area, and they might be adversely impacted. It's important to know that even though critical infrastructure operators and public safety officials should not be using this for critical operations, 2.4 or 5.8, which are the common frequencies for drones, people do. And so if you do jam on those signals, you might be creating adverse impacts for a lot of people in the area, including public safety or healthcare operations and stuff like that. So it's just a note to have in the back of your head as you explore any of these options. And those who receive training will get further into the details here. Next slide. I think I jumped the gun in explaining all the impacts. So we could skip ahead to the next slide, which I think is kinetic attacks. Nope, jumped the gun again. Sorry, guys. I kind of gave all the fun bits in those first two slides. So kinetic attacks. Right now, we'll focus our attention on net guns and attack drones. These are kinetic attacks that will kind of do as advertised. I think the next slide will have some good content and other images too. So with net guns, they come in different flavors. We've seen quite a few man-portable versions where an operator is kind of aiming and has a little indicator as to when to fire to have the most success with hitting its target. These net guns also come in fixed or mounted variants, and so there are a few people that will kind of create like a turret type device that shoots out a net gun. You get, I think, better accuracy and longer range. The advertised ranges we tend to see are about 300 meters. I like to think of this as like your last line of defense. All your other methods, maybe try to use a cyber attack, maybe try jamming, and none of that worked. And this is the last physical layer of defense before your drone gets too close to a target. You want to pull out your kinetic options. The other is a interceptor drone. We've seen more of these kind of gain popularity in the last few years, and they come in a few different flavors. One is where the drone is serving as a sacrificial UAS, kind of like a kamikaze style. It's going to go and hit the target drone and just at a high speed to kind of wreck both of them and have them crash. And then the other is a drone that might shoot out a net or have a net that it is towing on its own to try to capture the target drone. Both of these are likely to employ some type of onboard tracking and targeting mechanism, usually some kind of like close range radar, so that you can kind of move the understanding of where that target drone is from your ground-based radar to the onboard radar, and it has a little bit higher fidelity as it closes in. Both of these come with their own levels of collateral damage to take account for, right? Anything below ground in that area is likely to be impacted and maybe get some shrapnel or be directly below the moment of impact. Next slide. So understanding collateral impacts is huge. Anyone that receives their training will probably spend a lot of time on this. Just always think about the environment you're operating in. Are you by an airport? Are you by a sporting stadium? Are there a lot of people around? What kind of critical infrastructure is around for anyone who might make use of jamming techniques? And just kind of being keenly aware of what you're about to do. It probably goes a long way. Next slide. And then I will bang on this drum again. Currently, locating the operator is the most popular method. It's the most available method. If you can find the operator and engage with them in a conversation and have them land, most, from my understanding, 9 times out of 10, most people are just flying a toy they just got, and they don't know all the rules, and they don't know that they're doing something they shouldn't be doing, and they're likely to just land the drone and engage with you. Next slide. I think that might be it for me. And I'm going to pause here and just look at the questions list, right, Jared, just to make sure we're keeping up to.
Yeah, absolutely.
Okay.
Thank you, Bhargav. And before, fire away with your questions here. We can take them now. We can also take them at the end. We figure we have about 20 minutes at the end for questions after you've heard from 3 or 4 of us on a number of topics, but definitely put them in the Q&A. Throughout as you think of them, and if it's a good question, we might address it right away. But just a check on understanding for you, Bhargav. Mm-hmm. So you talked about smart and targeted jamming and versus broad-based jamming, and I'm wondering if you could reformulate for us. Is it wise to think about some of the smart jamming as maybe a first defense in depth strategy versus the broad based as a second defense in depth? What are your thoughts there?
Yeah, I would do that if those options are available to me. One of the big reasons is you're more likely than not going to have less collateral impact to those around you, which can mean less economic impact. It is just a more targeted form of approaching the threat in front of you versus a broad-based type of jammer. Mm.
Very good. So thank you so much, and fire away again with your questions for Bargraf as we see them. We'll pull them up. So, but now we're going to pivot towards test results. So New Steel has tested on for the department for DHS a wide range of components, sensors, and overall systems that bring together more one or more sensing modalities to give you an overall detection, to slew a camera, and so on. And we want to start the conversation on some of those example test results. But I do want to flag that today's webinar, we've limited the information to unclassed and publicly releasable information. So this is a bit of a teaser to show you, a range of performance that you might expect for different systems. But hop on the phone with us afterwards when you have specific questions, specific make and model, manufacturer, their vendor specs might say something. What did you guys actually see in an urban environment versus a rural kind of thing? So, but with that, there's still a lot to explore in unclassed space. So go ahead, Mitchell.
Thanks, Jared. And thank you, Barga, for giving an excellent overview of Counter-UAS. We have a great understanding now of what the terminology is, as well as what the threat chain looks like. So typically within DHS, we will classify and test equipment in these 4 categories: radars, RF systems, radio frequency, electro-optical, which is your visual camera, or RGB, sometimes it's referred to, infrared or thermal cameras, and then acoustic systems. Tested evaluation of these technologies is one government mechanism for evaluating this type of technology before major acquisition. There are other methods. Next slide, please. So one major document that is available and important to DHS as well as to state and local agencies is guidelines for test and evaluation of Counter-UAS technologies. This was a joint publication between DoD, DHS, and the National Security Council, came out in the 2019-2020 timeframe, and it sought to answer the question of how do we quantify performance data for Counter-UAS systems. There's an entire list here, and there's more in that document that we're happy to share with you. But the 4 that I would outline at the basic level are in bold. And number 1 is the probability of geolocation. So did you even see the UAS during a sortie? Kind of important, right? Number 2, ignoring line of sight conditions, which is an important consideration, right? But we got to start at level 1. Over the duration of the flight, we sample at 1 hertz or 1 data point per second of a sortie. What percentage of time did the Counter-UAS technologies persistently and correctly detect the UAS? This is represented as a percentage. Range, kind of self-explanatory, right? So we want to know the maximum range at which the Counter-UAS technology detected a drone. And then the 4th consideration is track accuracy. So on average, of all those data points where it detected the UAS, how accurate was the technology in geolocating the target UAS? Next slide, please. So now that we've discussed measurements of performance, we'll talk about radar technologies, and we'll start out talking about over the last 4 years at 7 different test events. We've tested somewhere along the lines of 20 different radars. These are every band you can imagine, every price point you can imagine, everything from the size of, a large book to something that is not man-portable and is hundreds of kilograms, right? So you can see here that over the last 4 years, we have 7 test events and 20 systems. On the next slide, I will go over the range categories that we have listed these radars in. This also lists the detection range that is claimed by the vendor. And in the next column, you'll see where it's green and says available. That means we have data for you. So reach out to us if you're interested in any of these radars or all of them. Email us, and we will be happy to provide you with that data. Next slide. So I'm going to go over a couple examples of how these systems are paired and how they are assessed. So example number 1 is a short range phased array radar. So it's a 3D phased array radar. It performs identification by a machine learning model It considers factors such as microdoppler, velocity of the target, radar cross-section, etc. And this is a low relative cost and size, weight, and power requirements system swap. So on the right side, you'll see our metrics, then you'll see our results. We typically bold the most important ones. Again, probability of geolocation in this test event was 65%. Maximum geolocation range, another important factor, was about 5 kilometers. And then the track accuracy in meters is about 14 meters. Example 2 would be another one that we'll look at. And this one's a little bit different because it's a combined radar and electro-optical infrared platform. So now we're looking at layered solutions. This solution presented to DHS was an X-band rotating radar. It offered 360-degree coverage in the lateral. It was combined with an EO/IR camera with fluid Q capability. And what you'll see on the chart on the right here is now, not only do we have the radar statistics, we also have the camera. So we've broken them out separately. You can combine them as well, but for the sake of this test event, we wanted to see what was the probability of detection for the radar, what was it for the camera, how good was it at classification, because you can imagine the input data to classify a drone from a radar is quite a bit different than a camera, right? So we wanted to know how that looked, and then we wanted to look at the probability of actually tracking that target, again, because that's a whole different method of tracking with a radar versus a camera. And then during one of these test events recently that we held about a year and a half ago, we were looking at the automation for slew-to-Q, slew-to-Q being a radar or an RF sensor cueing a camera to rotate to a specific location. Next slide, please. And finally, this is a little bit different of a solution. We still have a combination, but this time it is a omnidirectional passive RF detection sensor with real-time classification paired with a radar. And in this case, it was a lightweight and power-efficient radar operating on a mini solar panel. So you can imagine there's quite a bit of diversity in the power requirements of these systems as well as cost. Again, on the right side here, you'll see that we have RF results and we have radar results, both for probability of geolocation, geolocation range, track accuracy, and geolocation count. I think what's particularly important, why it's bolded here, is you can see RF range 4.5 kilometers, radar range 1.2 kilometers. So there is trade-offs with swap, size, weight, and power requirements, cost, etc. And if you look at our data, you'll start to see some of those trends. There's, of course, outliers, right? Those are really valuable to us because it helps us understand, if a technology is doing something new that has extra value, right? So that's example number 3.
Yeah, and it's a really timely question that Charles has brought here, so I want to jump right in and see if you can answer it. Do you have any comparison on how the multimodal technology impacts overall detection? You're showing individual RF sensor results here and individual radar results for a system. Do we have examples where we've tested a system and the system has, let's say a reduced false alarm rate because it's being cued by multiple sensors and you got to, get cues from all those 2 sensors or how many, give us some insights there.
Yeah, and that's one of the most important factors in why you hear recommendations of a layered solution, because there are a lot of false positives. At multiple test events, one of the most valuable things that we saw was because radars do have a lot of clutter. We're trying to detect drones that are the size of birds. Well, guess what? You're probably going to pick up birds too. So having the camera slew to cue on that target and automated algorithms saying, hey, that's a bird, I don't care about it, move to the next target, that's great. But the industry may not fully be there yet, especially with the solutions we're trying to field in a rapid manner. So even having an operator able to say, if it's, for example, an RF, radar, and camera solution, hey, I've got a radar track, is that real? Well, I don't have an RF track either. Well, it could be a dark drone, but let's slew that camera over to that target. Is there a target there? Maybe it's a balloon, maybe it's a bird, or maybe it is actually a drone, right? So yeah, we have seen the benefits of having multimodal systems, but of course there's always a caveat, and that caveat is cost and resource requirements.
Absolutely. So, and I would say, in our test and evaluation database, we do have some examples of system performance versus individual sensor performance, that comprise the overall system. So it depends on which system in question and which year we've done testing, whether it's rural testing versus urban and so on. So we can definitely bring up some of those details as they happen. And thanks for clarifying on the slewing the camera piece. We do have some performance data from a recent test where we did quantify the ability for cameras to slew or RF systems to slew a camera, and how well did that camera actually result on staring at that UAS target afterwards.
Yes, thank you. So the next piece of technology that we're going to talk about, we're doing two today. We're doing radar, and the next one is RF. The following slides will provide an overview of past performance results from various test events with RF technologies. This is particularly valuable to state and locals because the cost of RF technology is a little bit lower and typically a little bit easier to deploy than a radar that requires spectrum approval and things of that nature, right? These tests took place between 2021 and 2025. Next slide, please. So you'll see here in the last 4 years, if we're looking at purely RF only tests, we've had 4 test events and 18 systems. There are some vendors that are here twice. You'll see also that we've worked with our state and local partners extensively in the past. So we do have experience working with a state entity versus a federal entity. I think that's all I've got on this slide. The next slide will actually go over of the 18 to 20 platforms, what the vendor claimed, very important, vendor claim ranges are on the slide. And similar to the slide on radar, we have a green box that indicates if there is data available to your department, agency, et cetera. So reach out to us. And this is not exhaustive. There is probably 40 or 50 systems that we've tested in the last 5 years.
Okay, so we've had a few questions come in. I think a good one from Kenji. When you're talking about layered solutions, are you talking about a single point detection node, or are you also talking about multiple distributed detection nodes? And did your testing account for multi-node detection?
Yeah, that's a great question. How I would answer it is this. Multiple nodes of a similar sensor modality is not necessarily layered. When we talk about layering, that's talking about using different sensor modalities. Radar with a camera, camera with RF, RF with acoustic, or all 4 of them, right? Typically when we see nodes that are deployed in a larger area, it's to cover gaps in line of sight. So due to buildings or other obstructions, it's to increase the range, or it's to do, I won't go into details on this, but there are direction finding capabilities like time domain of arrival and power of arrival that you can use to not decode a packet in RF and look at the contents of it, because that does have legal implications. And we have looked at sensors that are distributed in manner like you're referring to, and we've also looked at layered solutions where multiple modalities are fused into one.
So in other words, if I heard that right, in some cases you may have a multi-node distributed system over, let's say, a couple kilometers, and that's one system. You might want to think of that as just one layer because it needs those 4 to 6 nodes just to operate to do that geometry calculation. Is that right?
Exactly. That is accurate. There's always a lot of nuances in this space, and that's why we're here to help.
Okay. You are no longer in the hot seat. Thank you very much. If I missed any questions, maybe you could respond by text for now, and we can always bring those back up. Otherwise, we're going to transition to this hot off the press tool that we'll have posted to our New Steel homepage real soon. We're just working through the final internal release process. So I'll pause here on the QR code, and that'll take you to our homepage. If you scroll down on the homepage, you'll look toward the bottom. There'll be a section that says resources, and then a subsection for that for Counter-UAS. And that's where we'll post this new tool. It's going to be a fillable PDF, and it's hopefully a more comprehensive way for you to say, look, I don't know where to start planning Counter-UAS. Maybe I've been to a training course, and I've only been thinking about a couple systems that I like. How do I plan my overall capability? How do I talk to vendors? What are the right questions to ask to get what I need? What if I don't even know what I need yet to then ask the right questions? So Bhargav's going to walk us through this rubric that we've created, and we'll post it, email it, and post it here pretty soon. So go ahead, Bhargav.
Thanks, Jared. Yeah, I guess we'll just jump into the next slide. What is the purpose? You heard Jared talk a little bit about it. The intent is threefold, and you'll see that through three different sections. It's one, to galvanize you guys to figure out what your capability needs really are in kind of a more vendor agnostic way. What do I need in terms of detection? What does my environment demand in terms of false alarm rates? What do the privacy policies in my organization require me to do? And then we try to align your own capability need with what's the right question to ask a vendor to make sure I'm getting the right information when I do go to a demo, when I do have a sit-down meeting, when I email them, when I'm looking through spec sheets. What answer am I trying to get to understand whether or not my capability need has been resolved? And then finally, the third part of the question is kind of that rubric part. What am I looking for that helps me evaluate whether or not my capability need has been met, or how do I rate that? The delta between what do I need versus what does that system have to offer. So we put together a rubric that should have somewhere on the order of 40 to 50 questions with, like, I think 15-ish categories. I think, no, let me back up. I think 12 to 13 categories. But this is a starting point. We wanted to give you a foundation to start on. It's really not an exhaustive or prescriptive list. It's configurable. You can add or remove categories. You can weight things differently. If interoperability is very important to you, you could give it a weight of 5. If modularity is not important to you, you could give it a weight of 0 and knock things out as well. So let's jump to the next slide. I'll give you a little bit of insight into the structure. So as I mentioned earlier, category 1, define your capability needs, right? You could use placeholders when you're getting into the more detailed things like metrics, like what range do you want your system to be able to detect that reliably? We also then create a mirror question for that capability need. How would you engage with the vendor to kind of get the answer you want? What kind of things should you be asking for that you might not know exist? As you saw in the last few slides from Mitchell, we test a lot of equipment. The DoD tests a lot of equipment. There might be test reports that they have access to, and you could ask them for a copy of it. A lot of the times they walk away with a presentation or a report that evaluates their own technology at these events. There might be training curriculum, service agreements, a lot of things that you might not know to ask up front that you can ask up front to figure out whether or not this technology and the services associated with it are going to meet your organization's needs. And then conducting that self-assessment, right? You've probably done a lot of things like this. The Uber 5-star method, a scale of 0 to 5 to help you and your team better understand whether or not a system is meeting your organization's needs. I would also say, I guess in the slide before we get to the next one is, when you're doing that defining capability need, you kind of want to have as many people on your team that might have a stake in this as possible. So, your OGC folks, your IT folks, your operators, just so that you're kind of all converging on the same set of ideas, or understanding that your ideas compete with each other and you're going to have to meet in the middle based on what systems make their way to you. All that being said, I know time is a big issue with these grants, and so use it as you see fit, and in a way that makes sense to you and your timelines. And to the right here are the categories we started with. Obviously, performance, interoperability, deployment, human systems integration. Those are the ones that we kind of focus a lot on when we do test and evaluation, but we wanted to make sure we're not excluding things like governance, cost structures, training and operation. So there's always going to be 3 to 5 questions in each of these categories to kind of get you going. I'll jump to the next slide. This is just a quick flavor. I think I pulled a total of 3 types of questions. I'm going to start from the bottom up, because I think when it comes to state and locals and to the World Cup, interoperability is super important. So that third question there is focused in on interfaces, data access, system control, common data formats. These are probably things you're not thinking of right away. You want to make sure that your system, first and foremost, can detect a drone, tell you where it is, find the operator. But these things become very important when you start to engage in activities and events where you need to coordinate with the jurisdiction next door or a federal entity. How are you going to get access to someone else's real-time data? How are you going to share with your partner what you're seeing? There's been a lot of workarounds over the years, but you don't need to have workarounds. There are tools that a lot of these technologies are creating natively, or that they can turn on plugins, features, APIs, so that you could send all this data to a command center offsite or something like that. So you'll see the capability need in the form of a question. Sometimes we'll highlight some documents you might want to ask for. And then right below that, the vendor question: what open interfaces are provided for data access and control? Which data formats are being supported? And then you could self-assess, right? What do the interfaces and formats support our integration requirements with our custom workarounds, and score that on a 0 to 5. So this is really meant to kind of be a self-eval tool that allows you to kind of chunk through really complex information in a more organized way. Next slide. I think that was all I have for the rubric. And as Jared said, we're trying to get this approved as soon as possible, and ideally it's out by the end of today, maybe worst case this week.
Yeah, absolutely. So just a check on my understanding, and then let's go to the Q&A box, see if there's any really difficult questions. I think I see one. I'm excited to see some of your answers here. But just to make sure I understand, Bhargav, about this tool. So I heard that there's 12 categories. I see that you've only included a subset of some of the questions to ask vendors, and various rows and columns. This may be a large and lengthy document. Can I use parts and pieces of it and tailor it to my needs?
Oh yeah, you could zero out entire rows. You can add questions to it. This is just meant to, get you 80% of the way there. You could use the whole thing as is if you go through all of it and see that it matches what you think your organization's needs are. We wanted this to be modular, configurable, something that you take to kind of make sense of the chaotic process of technical, high technical products being sold your way through complex acquisition.
Absolutely. I happen to have seen the near final version of this, and I noticed that there's some summary tables. Could one even worst case make use of those summary tables and have some way of getting to those numbers of 0 through 5 for each of the 12 categories to help make use of this tool to them?
So in I guess the appendix of the tool assertive, we created these summary tables, as you said, where you could total up your scores for performance, for mitigation, for human systems integration, for all those categories. And if you're evaluating multiple technologies, there's a table in there that lets you kind of compare across all those categories, compare total score. So then you start to have one clean place where you're in a more neutral, data-driven way, understanding how these different technologies stack up against each other as you're making what is a really expensive and difficult decision.
Yeah. Okay. Excellent. So, Tiara from FIFA planning team or committee there. I can't quite see her full organizational title. She asked the following question: what's the most robust system of systems setup that current laws allow non-law enforcement entities, so universities, private football club, facilities, etc., to set up, to have a robust as much as they can have the authority to operate, kind of thing?
Yeah, I'm not a lawyer, and you put the word legally at the end there, and I know there's some lawyers on the line here. So I will say a multimodal system. There are radars that are FCC approved. There are radars that you can get approval for use in most of the country that are still considered experimental. Just about doing some of the legwork. There are RF systems that are already being deployed by state and locals, and critical infrastructure operators. Always consult with your own OGC or legal counsel to figure out what is considered allowed or not allowed. I know just about all of these counter-UAS technology vendors will still sell it to you. And so you want to make sure you're not exposing yourself to unwarranted risk. But there are a lot of tools out there, and Mitchell beat the drum on it a little bit earlier. But multimodal, just try to make sure you have a technology that has different types of sensor modes. And in an ideal world, maybe you have some sensor fusion so that you're not having to look at separately a radar track, a camera track, and an RF track, something that kind of brings it all in together to reduce the load on your operator. But there are some good options out there. We're, a government lab that tries their best to be independent, so we will never give a name or put one recommendation over another. There's never going to be a silver bullet, but we can kind of guide you towards your subset of solutions based on your specific needs.
Yeah, absolutely. And I love the way that Tiara forms the question, because she's obviously been listening to this idea of defense in depth, multiple approaches, overlapping fires, all these kinds of things. She did ask explicitly, can they use radar and RF systems legally? And the answer is, as Bargov said, yes, with some caveats. On the radar side, with FCC registration, RF systems, depending on the type of system, and so on and so forth. But yes, I think Chiara is you're hitting the nail on the head. There's absolutely a way to have a robust detect, track, and ID only kind of capability that would be legal for these subset entities who don't have mitigation authority. All right, so we are. I think there are a couple more questions in the chat, and perhaps our team, as you see some and you're able to answer, feel free to do so. I see one from George Purdy about a particular system. If we don't have anyone that can answer in a way that is allowable in this venue, or otherwise we don't have the information, then just make a note that, hey, we can always look into that. But otherwise, we're going to move on to this idea of, okay, so you put your grant in, you've made some this high-level plan. You're now getting to the point of some equipment deliveries. And what are some of the tools that NewSteel could help with in these later phases? Are there some map-based analyses, whether it's line of sight analyses, whether it's looking at providing sort of a short list of potential rooftop locations that might make sense from an elevation or other considerations? Are there on-site RF environmental surveys that would make sense in certain cases? And what are some of these various advisory services that we can offer here? We have a variety of things, and we have a guide for you, but we don't have unlimited individuals. We have a small team. Alex is going to represent some of the things that we can do here. So go ahead, Alex.
Thank you for introduction, Jared. I'm Alex Ednov. I'm general engineer at NewSteel, and I've been focusing on analyzing the sensor performance and the factors that affect them. Primarily, what sort of map-based analysis can we apply to predict the sensor performance depending on how they're deployed. So as Bargov mentioned, most sensors that provide detection, track, identification are limited by line of sight. So in urban terrain, it's incredibly difficult to plan for line of sight because it's very complicated. There are buildings, trees, all kinds of obstructions that can affect line of sight. In the map, in this image, you can see just presentations of line of sight in the same area, depending on where the sensor is deployed. So you can see that the area, the total area covered, represented by color, is varies dramatically depending on how the sensor is deployed. So to produce this kind of analysis, we rely on high-resolution height map data, and in a very wide area, because some sensors could cover very far, but at the same time, we have to analyze the entire area where the obstruction might arise. A three-dimensional representation of this can be seen in the bottom left picture, where you can see that some features could just block a volume. So there's going to be a certain height under which you cannot detect a target because the energy just doesn't propagate through solid obstruction or even a tree canopy. So To do this, we need to source the height map data. Typically, it's derived from LiDAR, and it can be provided by multiple government agencies and other sources. And we have several tools to rapidly source the data and compute line of sight for many possible sensor locations. Can you see the next slide, please? Typically we have to combine data from multiple sources, reconcile it with what is most current, combine them, and sometimes even edit. In preparation for the event, we have sourced data for all host cities in the vicinity of the event venues. You can see images of from Seattle to East Rutherford, New Jersey, but we have reconciled the data, and we're prepared to analyze the sensor placement. Could you see next slide, please? Sometimes in a wide area, it's very difficult to pick a concrete location, and the sensor end up getting deployed where the access is provided somehow, which could be not optimal. Sometimes you have multiple goals. You need to cover several areas using a single sensor. And to narrow down those locations, it's beneficial to have some sort of a tool. And we have developed a tool we call it reverse line of sight analysis, where basically we set the goals of coverage and we narrow down the deployment locations to just maybe a few rooftops. And from there, you can analyze whether it's accessible and perhaps contact the entity that might control the venue and coordinate the access, which is going to be much more efficient than trying to coordinate access to just some location that might provide the coverage, yet it's not clear whether it actually covers all the regions that you intend to cover. Next slide, please. Multiple sensors, primarily passive RF receiving sensors, so sensors that either even decode or maybe just look at spectrum shapes, would be affected by the presence of powerful transmitters next to them. You would not like to deploy it next to a transmitter, Wi-Fi infrastructure. You don't want to deploy it next to a cellular base station. So sometimes you can identify the antennas that affect you. However, radio waves are invisible, and therefore you might not actually have a fair assessment just from examining a venue whether there is going to be a strong interference. So we have developed a survey setup that we can take inside the venue, and we can map the interference, the transmissions that exist close to the bands where drones operate, and create a basically green and red mapping of go, no-go decisions. Also, the radio frequency interference could be very varied. On the graph on the bottom left, we can see pretty much variation of energy received by a sensor deployed at a stadium venue. So while there's no crowd or no staff, the activity might be quite limited and not interfere with detection. So the sensor, in some sort of hypothetical test situation, might perform rather well. However, as the mass event ramps up and the crowd gathers and all the transmitters are getting activated, the interference may be increased greatly, and we have analyzed certain locations within stadiums to predict that. So we can provide this sort of support based on request, and we can predict whether sensors make sense to deploy at in a certain particular location and give you feedback. Map-based tools can help you plan before and analyze the results after. Over.
Okay, great. Thank you so much. So just a check on learning for me, a couple of questions for you, Alex. Is it fair? Did I hear this correctly that RF surveys are important to conduct on site to understand where you might have noisy RF environments in that micro location? 50 feet this way, good. 20 feet that way, really bad. Avoid that area.
Certainly, primarily because the spreading is the dominant factor for at short range. Basically, the spreading of energy is the dominant factor of the attenuation. So if you're really close to a transmitter, it might not even be in your band, but it might affect you. Therefore, you would like to identify the location of a transmitter and provide standoff distance. Certain vendors will outright say, don't locate us 30 meters away from as close as 30 meters to, let's say, cellular base station, although they technically don't look at those bands. And that was our experience at some of our events we have attended.
Is that true for radar systems and passive RF?
Not always. However, the radars might have a backhaul that might conflict with the transmitters that are present. Typically, radar bands are very far away from the typical transmitters that you might find on roof. However, there are certain transmitters less typical and KU band. Also, S band is popular for drones. It's become more popular for drones, and you might actually destroy some of the receivers if you collocate with those.
I see. So you could have impacts to the stadium.
Yes.
In the stadium's infrastructure. Interesting. So is it fair to say that map-based analyses should be done to consider the entire system or system of systems that's being brought to bear with different, stadium DTI-only assets, perhaps with federal assets that are going to be deployed for certain portions of events, and then the state and local new mitigation assets?
Yes, certainly. Basically, different sensors have different coverage, and therefore, so coordination is very important that the assets are deployed in a way that they do not conflict, and they cover. Basically, their coverage is deconflicted, which means you don't have redundant coverage where you don't need it.
Absolutely. Okay, and I hear Kenji's agreeing with all this so far. So I want to come back to Charles's comment. It's important to follow and this is back to Bargov's section on this Counter-UAS equipment selection tool. It's important to follow the FEMA Notice of Funding Opportunity, or NOFO, to see the grant requirements and scoring and technologies and later layered approach. I just responded very briefly, but in case folks are wanting to see this in recording. Yeah, absolutely. Our selection tool explicitly mapped to this Notice of Funding scoring criteria that, there's 100 points when you read it, and you get 2 points for this or that. You get 30 points for another thing, get 50 points for mitigation considerations, and so on and so forth. So we have mapped to all that and tried to also explain what's some of the rationale behind some of the scoring, there is rationale behind it. So I'm wondering, I do see a question from Robert Del Rocco. Any feedback on vendors for wide area DTIM software as a service? Maybe one of you guys can jump in and add or explain your written responses already, Bargov or Mitchell. But we do have a market survey report that Science and Technology Director at S&T did assemble recently that has handy dandy tables for different systems and what they include and are capable of and things like that. Is that accurate, Mitchell?
Yes, that is accurate. And then going back to his question, it's great to see you on the call as well after the emails earlier this week and last week. Be careful of the M part of the question. Bargov alluded to it earlier. The vendors will sell you whatever makes the money, right? So we have to be very cautious about what they're coming to you and trying to sell you and give you the ability to have. And even if you don't use the mitigation part or you don't use the decoding part of it, now you have technology in the hands of a state agency that can do that. So that adds another wrinkle to the layer there.
Mm-hmm. All right, Barga, if you feel free to add anything to respond to this question, great. If otherwise, we can continue on the chat there. But yes, we do have a report and that is releasable. We have some nuggets from that are also releasable. So we are in this general Q&A time period. We have plenty of time for questions. You may not get answers that that you find helpful. Hopefully you do. But I'm going to go through here and try to nominate some of these questions. I need to scroll down because maybe I've missed some earlier. Layered solutions. So I think we've covered that.
Yeah, I do want to talk to that just because I was thinking about something, Jared. When we talk about layered solutions, we have a lot of agencies that come to us that get excited about having, nice cameras and radars, and I need to ask for a $5, $10, $15 million budget. And you're a small agency, that's just not feasible, right? This funding is certainly helpful, but when you look at protecting the entire homeland, 50 states, it's a massive problem to solve. So there is merit to focusing on RF only detection early on, just to get an idea of what's in your airspace. I personally don't necessarily think remote ID is that helpful of a standard, but if the sensors are cheap enough, it can give you an idea of what is there. And then if you have another UAS in the vicinity that is not correlated with that, you can draw some conclusions based on that. So I want to reiterate, the layered solution is a long-term play, but even at the federal level, looking at our partners in DoD, it's a big resource problem to deploy those solutions. It's a lot of work to try to perform that sensor fusion. How do you prioritize and quantify whether a camera is more accurate than a radar or an RF sensor, right? So we're moving towards that space. We're catching up ourselves right now. Don't get too caught up in immediately deploying all these layered solutions and trying to do all the hard work all at once. Start with something that's familiar with your department, starts within the scope of what your team's capabilities are, and then scale from there.
And hopefully use our scoring tool or equipment selection tool to assist you in that process. I do want to note, though, that the remote ID does, including that in your grant application, does give you 2 points for whatever that's worth. Dara, correct me if I'm wrong. I'm just recalling that. There's so we did have a question that I just want to, we don't need to explore the answer. We have some written responses. I just want to flag that Hugo asked, as of today, who has authority to utilize Counter-UAS equipment. We do have a couple of responses there, including from Paul Dawson, who is sort of the authoritative answerer there. The team's pointed you to some resources in the NOFO and et cetera, so that you can understand the authorities and the evolving legal landscape. So I'm scrolling up now. So Jason Stanley, presentation available in the Drone Responders link. It will be shared. You see the pre-decisional draft notice until we just get this cleared through security, but we'll get it out there a few different ways. Absolutely. We do have a question from Kenji or a comment. Maybe there is a question implied here. RF surveys are super important. There are so many sources of RF noise. Also look at spurious RF sources. So we have, that was back to Alex's presentation, some comments there. Next question from Ryan. Are those LiDAR scans of the host cities available somewhere? Alex, do you want to explain how these, we don't have releasable and useful tool that would work for operators yet. We're definitely heading down that path with R&D. In the meantime, we do have data sets that we are pulling from. Do you want to just go into a little more detail, Alex, of how you can do that for different sites of interest and where you look? Sometimes you look for different LiDAR data sets in order to do that, right?
Yes, so we will combine various LiDAR data sets. We are sourcing from NJ Grid, as well as the public data sets that are available on Amazon.
And just to pause there, a lot of acronyms. We did put some acronyms in the back of the slide deck when we sent it out. NGA is the National Geospatial Intelligence Agency. They have a program called GRID, which is also an acronym, and it stands for something like Geospatial Repository of Data, something like that, but has a bunch of LiDAR data. Yep, go ahead.
Yes, we have tools to source them rapidly and convert them to digital share models that we combine and manually inspect to make sure that none of the artifacts actually made it through the outlier filters. Then we analyze the sites. Sometimes we have to, let's say, there is a balcony where you're deploying, and sometimes we have to force the location of a sensor to, like, somewhere in the middle of a building to provide fair analysis. We assign regions of interest to focus the analysis. Typically, we just analyze by just a cutoff range for a sensor. However, we do also have analysis tools for multinodal sensors that where you have to take into account the individual node detection, as well as the geometry of placement and other factors. We have, because radar sometimes have limited, not 360-degree detection, or we have TDOA based detection, where we have to have very complicated geometry. The geometry is called, so two TDOA nodes would give you a surface known as isochrone, so it's a hyperboloid, and when it intersects basically the possible location of a drone, it's more of a hyperbola, and the intersection of this is very complicated. So we have tools to quantify the precision of detection depending on the sensor placement. But since typically we limit the number of locations we consider, we can just fairly just rank whether a certain combination of rooftops is going to give you coverage or not.
Absolutely. And that's probably pretty important for systems that have multi-nodes, right? Doing that analysis. So we had a question from Christopher. FBI course, is that going to stay 3 weeks long down in Huntsville? Unfortunately, it's probably not good for us to speculate. We did include their email link that you could ask them directly. That's back on slide 4 or something. I can pull that back up in a second. For those or other questions about the training course availability, all sorts of things like that. We do understand that having got.
I did hear that they were looking to move it to 2 weeks and doing some of the work they could online to overcome some of that, to shorten the period of time for people being there.
Great. Thank you.
I can see one of the SSAs is trying to raise his hand and perhaps give us a direct answer. Not sure if we can unmute him.
We may have. Yeah, we may have a functionality issue in being able to pull that off. But if Abby can do it, she will. Otherwise, feel free to respond directly in that Q&A there, Special Agent Brian, hopefully. So we have another question from Charles. Looks like it's already been answered by Dara. Currently, only agencies that can purchase mitigation technology are those that are either trained or on the training list. And then Dara point you to the authoritative information there. in the NOFO. Ryan asks, how can we access that report? That was 8 minutes ago, so I'm not sure
I
which.
think he was talking about the Saver report where he kicked the question over to Mitchell.
Oh, yeah. Okay. So just reach out to the New Steel inbox asking for that that report and any information around the wide area DTIM capabilities, and we can absolutely share that as a FOUO. Charles made a comment in DHS's presentation at GMU. They referenced optical, acoustic, RF, and radar sensor combos. Did you want to add anything there, Charles?
I think
Certainly, we've covered that.
it goes back to what was being discussed earlier about how you integrate all of those sensors into the system was the question.
Yeah, absolutely. Okay. TR asked a question, does RF detection impact live video and audio broadcasting, or does it only impact a live broadcast if the mitigation features are used? And so Bargov responded, but just for folks on the recording, RF detection tends to be passive, so it won't impact the video or control of the drone. On the mitigation side, RF are directed at the command link, which may or may not be separate from the video link. So long story short, on the mitigation side, he goes, depends. Okay, let's keep scrolling up. Sometimes it's hard to, okay, so I see Special Agent Oakley's response here, 2 weeks, of course. If anyone has noticed that I have skipped a question, feel free to chime in.
And then SSA Brian Oakley is also one of the instructors at the course. So if anyone has any questions, maybe we can shoot him his way.
Yep, the inbox. So I'll go back to that. Give me a second. Is somewhere around here. Here we go. Oh, so I was misremembering. So the could someone put the NCUTC help desk or email link in the chat here? We have it in our tool, but I don't have it on this list here.
Yep, give me a minute, I'll do it.
Okay. Yep, it's pretty early on in our tool. All right, so let's see, do we have additional questions? Ben Call, is there a New Steel recommended software that can integrate multimodal sensor feeds into one easy to use interface?
I'll take that by first saying we generally don't recommend single products or software, but common operating platforms or common operating pictures are kind of the category of things you want to look for that allow you to receive multiple feeds from different types of sources, one of them being a Counter-UAS technology. And then there are different like data model interoperability layers that you want to look for. A popular one that's free and that's used by the DoD, DHS, a lot of state and locals is Cursor on Target, which feeds into things like ATAC, which is also free to acquire. You just have to set up your own server. But there are other commercial options out there too.
Right, and TAC is an acronym, but TAC.gov, because if someone could put a link here in the chat to respond, that's one example within this, top space. TAC is an acronym, stands for Tactical Assault Kit, I believe, and developed, was it originally developed by DIU? I don't recall, Margot.
DoD.
DoD.
It was DoD. It's a team awareness kit, and if anybody's interested, Drone Responders has a TAC working group. If you want to learn more about it, we also have a TAC sandbox that you can play in it to see how it works, but it integrates different type of data sources to create that common operational picture.
And I'll close out that comment with Ben, is actually one of our partners at Department of State. Ben, reach out to us on the side because you're on the federal side. There is a common operating picture that DHS is working on that may be interoperable with your team. But we had to answer the question, of course, for the state and locals as well on the call. But reach out on the side and we'll be happy to help you with that.
So Bhargav, can I summarize your response as there are a number of options? TAC is one that's being used, and it's actually being used by fire departments around the country increasingly, including for joint, PD and fire department type large operations in a number of cities. But we do have information on different options out there. We also have don't we have a 1 or 2 pager on TAC?
Yeah, we do. I can share that to anyone who needs more info.
Or post a link if we do have a link.
Sure. Yep.
All right. And Anthony asks, many public safety agencies are being driven towards Axon Dedrone due to the ease of procurement, due to existing contracts. Is this a solution that your team has tested and evaluated? Mitchell, do you want to respond to this in some of the, should I go back to some of the slides that RF results and others, or do you want to just a general answer?
No, I'll give a general answer. So the answer is yes. We've assessed it on multiple occasions, both at the federal level as well as the state level. We're very familiar with that platform. We're very familiar with how they integrate with public safety agencies, because we also work on the UAS side of the equation. So we're aware of how they've partnered with Skydio, and some of their integrated solutions kind of makes it a easy integration, so to speak. So yes, we are tracking that. We can give you performance data on the Counter-UAS side, and we can also connect you with some of our partners on the call that have deployed their solutions both in New Jersey and Florida, and otherwise if you want more data on that.
And we're also aware of different things that they are capable from their interface, including ingesting different radar types and things like that. Is that fair to say?
Yeah, their data fusion and sensor fusion, we have intimate knowledge of working with that. Yes.
All right. Thank you, Bhargav, for posting the TAC link. It's not directly in the question. It's Bhargav has posted that separately. Okay, great. So Special Agent Oakley also mentioned that they use TAC and cover it in the training. So it's great. Did I miss any questions?
I had a question sent to me about if you're purchasing things like radars and stuff, are there any other things like FCC approvals that have to be done?
Yeah, I would always ask the vendor if the radar has an FCC license, and if it doesn't, it most likely will have what's known as a stay or an experimental license, which is granted sometimes throughout the whole country, but oftentimes with a time limit on it. And so it is just a question, if you want to do your due diligence, to ask the vendor. There are a few out there that are fully licensed and able to operate anywhere.
And if it's in that temporary authorization, stay is Bhargav is an acronym Bhargav use, special temporary authorization.
Yeah, sorry about that. Yep, correct.
Justin asked a question, is there any work being done to create a vendor agnostic repository for RID captures from various counter-UAS systems? It seems that many of the systems being fielded are siloing this data in their own proprietary database. One would hope that for investigative efforts, this sort of effort would be helpful if it was all in one place.
I can take that, Jared.
Okay,
Mitchell
thank you.
definitely wants to take that.
Yeah, I'll leave my personal opinions out of the matter because I also come from the hobbyist side of the equation. But FAA is currently doing that with what's called network remote ID. So they are attempting to centralize and use that data to correlate with things like LANCE authorizations, so authorizations to fly in controlled airspace. that are pre-approved, as well as certificates of authorization or a waiver for controlled airspace or BB loss operations, etc. That is in the FAA's court. There is a tool called the Discover, DISCOVR API. I believe it's actually located within the Homeland Security network, so it's kind of hard to access unless you've got someone on your team that has access to like a DHS liaison. So to answer your question, yes. Is it available to state and locals? No. Are we moving there? Potentially, yes. It's not within Homeland Security's court, so I don't mean to just punt that somewhere else, but that's all the information I have on it at this point.
Thank you, Mitchell. Okay, so I don't see any further questions. We'll continue to pause here as you're thinking of things. I'm aware of, obviously, this has been a long period of time already for folks to dial in. So soon, I think we will feel free to come and go as you please. We'll continue to record this as folks do continue to linger with questions. So if someone could just drop in the chat to respond to Robert, the New Steel inbox email.
Yeah, already taken care of, Jed.
But yep, that'll be where we field your questions. So I think we're getting close to wrapping up. So I want to at least take the time and thank Charles. He impressed upon us the need to get this information out urgently. Give us something, even if it's unpolished. We rapidly put together this tool after a conversation with Charles, and I want to thank our team for a lot of hard work and scrambling to put together this tool that Bargraf mentioned sort of towards the middle. This full fillable PDF, and then the presentation we will get out a couple different ways, email, etc. We'll post to the website, the tool at least. We will treat that as a version 1 tool. We've had very limited time to get external consultation from you all to say, you know what, give me this kind of functionality to make it more useful. Give me this kind of content or remove some of this content because it's just too much, that sort of thing. So we really would appreciate any feedback that you guys could give us on the tool once we release it, and happy to do that through our New Steel inbox, or if you're already in communication with some of our engineers or something. So please do collaborate with us on improving that tool, because it's a scalable solution that we can offer as we look forward to FY26 and then also FY27 in particular. We're talking to 11 host cities and NCR right now, but beyond for FY27 grant funding allocation, and separately, folks eventually are just going to start using their own internal resources to purchase this equipment, because that's how important it is. So as you get access to the FBI training course and have the authorizations and so on. So this tool is one of the few things that we have that's scalable. We don't have a bunch of Dr. Sedanovs sitting around. So, but we definitely also want to work with you on different customized support. So Alice, did you want to add anything there?
No, I just want to thank everybody for taking the time today. There was an item in the chat regarding FCOs. Definitely reach out to your FCOs if you're supporting World Cup. This is more than just a technology issue. There's obviously a lot of coordination aspects, and the FCOs are definitely your belly button for that. In terms of engineering technical expertise on the products, whether it's Counter-UAS or weapons screening systems or crowd count applications, that we're your belly buttons for that. So and we're working with the FCOs as well. So definitely reach out to them on World Cup, as well as us for the technical and engineering expertise.
Yeah, absolutely. Thank you, Alice. Charles, did you want to add anything to wrap it up?
Yeah, I wanted to thank you for taking the time to quickly pull this together and get the information out there. I have one question. As this goes forward, you're obviously going to have more questions. It's a possibility that from this, that we're able to capture and build a more frequently asked questions of what you're getting from people and what you're learning. Because there will be next round, the money that comes out in 2027 to do something similar, perhaps.
Yeah, absolutely. You broke up a little bit. I did hear your suggestion of compiling a frequently asked questions. I think it's a good idea, and we'll start doing that. We definitely want to have another broad venue to have later on in FY26 for folks to come back and maybe we, as part of that, we try to do a little homework and figure out who wasn't invited that might ought to be invited for the next round and add them. Maybe we fix the ability to present slides to a very large audience. We had some delays there with the slides showing up, hopefully just early on. But yeah, so we should make this not necessarily a series, but have a couple events like this.
Yeah, definitely, Charles. I would say, for all of those people who are on the call, let us know what you need, whether it's through the New Steel inbox or through Charles, because part of it is, we try to keep our fingers on the pulse of what state and local responders need. But, especially with things like this where things are moving really quickly, we want to be agile and responsive. And so the more requests that we actively receive, the more quickly we can respond to the larger community. And I don't want to just, make this a World Cup thing. Obviously, this counter-UAS issue is a longer term problem. And, we're here for more than just the World Cup. And again, more than just counter-UAS as well. So definitely reach out to us often. We're here, we're a free resource. You know us all now, we're all friends. Don't be afraid.
So with that, I'll pause for any final questions. Otherwise, thank you everyone for joining today, and forward to staying in touch. Okay, take care.